NASA's spacecraft that's been exploring the universe for nearly 5 decades is back on the space agency's radar. NASA lost contact with its Voyager 2 probe last month, but a heartbeat signal from the craft has been picked up during a regular scan.
Voyager 2 should not still be talking. It was launched in 1977 for a mission that was supposed to end after the outer planets. But nearly 50 years later, a faint signal is still crossing billions of miles back to Earth. And what that signal says is not comforting. It tells NASA that the edge of our solar system is hotter, denser, stranger, and more unstable than the old models expected. The warning is not that something is coming for us. The warning is that we barely understand the shield protecting everything we call home. The message that takes almost a day to arrive. Every signal from Voyager 2 is already old by the time NASA hears it. That is the first thing that makes this story feel unreal. When the spacecraft sends data back to Earth, the transmission has to cross a gap so large that light itself takes many hours to make the journey. A command from Earth takes many hours to reach Voyager 2, and the reply takes many hours to come back. This is not a normal conversation. It is a 2-day exchange with a machine built before the modern internet, before smartphones, before most of the engineers now watching it were even born. That delay changes everything. If something goes wrong, NASA cannot simply adjust it in real time. Engineers have to send a command, wait, hope, and then wait again. By the time they know whether the spacecraft listened, an entire day can be gone. That is why every transmission matters. Voyager 2 is not just far away. It is far enough that even hope has a delay. The example script understood this perfectly. It began with distance, not with a generic space fact. That is the right instinct, because the drama of Voyager 2 is not only what it found, it is the fact that anything from it still reaches us at all. This is a spacecraft running on fading plutonium, carrying 1970s technology, sending whispers from beyond the sun's protective bubble. Every signal is fragile, every update feels borrowed, and one day, the next reply simply will not come. The grand tour that should have been the end. Voyager 2 launched from Cape Canaveral on August 20th, 1977, riding a Titan IIIe Centaur rocket into one of the most ambitious flight paths NASA ever attempted. The mission was built around a rare planetary alignment that allowed a spacecraft to use gravity assists from the outer planets. Jupiter would fling it towards Saturn. Saturn would send it toward Uranus. Uranus would redirect it toward Neptune. This kind of alignment does not happen casually. It was a narrow window, the kind of opportunity that forces a civilization to either act or wait generations. For the first part of its life, Voyager 2 did exactly what it was sent to do. It visited Jupiter and Saturn, then became the only spacecraft in history to fly past Uranus and Neptune. That alone makes it irreplaceable. Every close-up image we have of Uranus and Neptune from a passing spacecraft comes from Voyager 2. The blue worlds at the edge of the planetary system were no longer just distant dots. They became real places with rings, moons, storms, magnetic fields, and mysteries that still shape science decades later. But the planetary mission was only supposed to be the main act. What nobody fully expected was that the afterlife would become even more important. After Neptune in 1989, Voyager 2 kept going. The cameras were eventually turned off. The famous images ended, but the instruments that measured particles, magnetic fields, plasma, and cosmic rays stayed alive. The spacecraft stopped showing us planets and started showing us the invisible architecture around the solar system. The shield around the solar system. Most people picture the solar system as planets orbiting the sun, but the sun does more than shine. It throws out a constant stream of charged particles called the solar wind. That wind expands outward, carrying the sun's magnetic influence deep into space. Together, those particles and fields create a vast bubble around the solar system called the heliosphere. Inside that bubble, the sun still matters. Outside it, the galaxy begins to press in. That is the shield Voyager 2 eventually reached. Not a physical wall, not a glowing dome, not something you could photograph with a normal camera, but a boundary made of plasma, magnetic pressure, cosmic rays, and particles moving between stars. This boundary is called the heliopause. It is where the solar wind's outward push finally loses to the interstellar medium, the material that fills the space between stars. Voyager 2 crossed the heliopause on November 5, 2018. That was the moment it entered interstellar space in the scientific sense, beyond the dominant flow of the sun's plasma. It had not left the sun's gravity completely, and it had not escaped the wider Oort cloud region, but it had crossed the sun's protective plasma boundary. That made it one of only 2 human-made objects ever to operate outside the heliosphere, along with Voyager 1, the transmission that changed the models. When Voyager 2 crossed that boundary, the data did not behave as neatly as old diagrams suggested. Scientists had modeled the heliopause for decades, using theory, mathematics, and indirect observations. But theory is not the same as touching the boundary. Voyager 2 gave NASA something rare: direct measurements from the crossing itself, including data from its plasma science instrument, which Voyager 1 did not have working when it crossed in 2012. That is where the warning begins. The edge of the solar system was not a calm, clean transition. It looked sharper, denser, and more complex than a simple, soft border. Cosmic rays increased. Solar particles dropped. Plasma conditions changed. Magnetic fields behaved in ways that forced scientists to refine what they thought they knew. The heliopause was not just a line on a chart. It was a violent meeting place between the sun and the galaxy. This matters because the heliosphere is not a decoration around the planets. It helps shape how cosmic rays enter our region of space. It affects the radiation environment future deep space missions will face. It tells us how stars interact with the interstellar medium. It may even help scientists understand habitability around other stars. Voyager 2's data warned NASA that the shield around our solar system is not simple. It breathes, shifts, compresses, and reacts to forces coming from both inside and outside. The wall that is really a storm. The title says, Voyager 2 warned the world, but the warning was not a spoken message. It was a pattern in the numbers. The edge of the solar system behaves less like a wall and more like a storm front. Solar wind pushes outward. Interstellar material presses inward. Magnetic fields wrap and bend. Particles accelerate, scatter, and leak. The boundary expands and contracts as the sun's activity changes. In one era, it may push farther out. In another, it may pull inward. This is the original twist of the improved version. Voyager 2 did not find a danger approaching Earth. It found that our cosmic safety zone is dynamic. We live inside a moving shield, not a permanent fortress. That changes the emotional meaning of the mission. Humanity is not sitting at the center of a neat, protected clockwork system. We are inside a bubble flying through the galaxy. And the 2 oldest spacecraft we have are the only direct witnesses to what happens at its edge. That is why Voyager 2's final years matter so much. It is not just an old machine sending nostalgic signals, it is a dying weather station at the border of the solar system. Once it goes silent, we lose one of the only direct voices reporting from outside the heliosphere, the Uranus mystery that took 40 years to reopen. Voyager 2's warning did not begin in interstellar space. It began much earlier, in 1986, during its flyby of Uranus. That visit remains the only close spacecraft flyby of the planet in history. Everything we know from that angle comes from a single pass by a single machine. And for decades, one piece of that data bothered scientists. Uranus seemed to have a surprisingly strong electron radiation belt, far stronger than expected for such a strange, tilted, distant ice giant. For years, that mystery sat unresolved because there was no second flyby to compare it with. Imagine trying to understand Earth's weather after one airplane flight through one storm on one day. That is what happened with Uranus. Voyager 2 gave humanity a priceless snapshot, but it was still only one snapshot. If the planet was behaving normally, then Uranus was stranger than expected. If Voyager 2 arrived during an unusual event, then scientists may have spent decades interpreting storm data as if it were normal weather. Recent research from the Southwest Research Institute suggested exactly that possibility. Scientists proposed that Voyager 2 may have flown by Uranus during a rare solar wind event known as a co-rotating interaction region, which may have supercharged the planet's radiation environment. If that is right, then one of humanity's most important planetary datasets may be partly shaped by a cosmic coincidence. Voyager 2 did not lie. It told the truth about what it saw, but what it saw may have been Uranus during a storm. One snapshot can become a textbook. That Uranus mystery is one of the best storylines because it shows how fragile knowledge can be at the edge of exploration. People often imagine science as a huge archive of repeated measurements, but sometimes our understanding of a world is built on one flyby that lasted only a short time. Uranus is not like Mars, where orbiters, rovers, and landers keep adding data. Uranus had one visitor. Neptune had one visitor. Voyager 2 became the only witness, and for decades, scientists had to build models from what it sent back. That is the deeper warning. At the frontier, a single transmission can shape an entire generation of science. If that transmission catches a planet during an unusual moment, we may misunderstand the planet for decades. This does not make science weak. It makes exploration humbling. The first answer is not always the final answer. Sometimes a spacecraft does everything right, and scientists still need 40 years of better theory, better comparisons, and better solar wind physics to understand what it actually saw. This is why another mission to Uranus has become such a priority for planetary scientists. Voyager 2 gave us the first look, but it cannot give us the second. It is already gone, billions of miles farther out, and it will never return. The spacecraft, NASA, is slowly turning off. The most painful part of Voyager 2's story is that NASA is keeping it alive by shutting it down. The spacecraft is powered by radioisotope thermoelectric generators, which convert heat from decaying plutonium into electricity. That power supply weakens every year. NASA's own material says the Voyagers lose about 4 watts of power annually. 4 watts sounds tiny on Earth, but on Voyager 2, every watt is life. Over the years, NASA has turned off cameras, heaters, instruments, and non-essential systems to save power. These are not casual decisions. Each shutdown means a capability is gone forever or effectively lost. In September 2024, NASA turned off Voyager 2's plasma science instrument to conserve energy. That was especially emotional because the same instrument had been crucial in confirming Voyager 2's crossing into interstellar space in 2018. It helped prove the spacecraft had passed beyond the heliosphere. Then, to keep the mission alive, it had to be sacrificed. As of 2026, NASA's instrument status shows Voyager 2 still has only a few science instruments operating. The spacecraft is alive, but not whole. It is being reduced piece by piece so that its most valuable remaining instruments can keep speaking a little longer. That turns the mission into a countdown. Every transmission may contain science no future spacecraft can collect for decades. Every shutdown buys time, but also removes a sense, the antenna mistake that nearly ended everything. In July 2023, NASA nearly lost Voyager 2 because of a tiny mistake. A planned command sequence accidentally caused the spacecraft's antenna to point 2 degrees away from Earth. 2 degrees is nothing in daily life, but at more than 12 billion miles away, 2 degrees is the difference between communication and silence. Suddenly, Voyager 2 could not receive commands or send usable data back to Earth. NASA detected a faint carrier signal, proving the spacecraft was still alive, but the normal data stream was gone. The team knew Voyager 2 had automatic orientation resets scheduled, but waiting months would mean losing valuable time. So engineers used the Deep Space Network facility in Canberra, Australia, to send what NASA called an interstellar shout across more than 12 billion miles. The command told Voyager 2 to turn its antenna back toward Earth. Then NASA waited. The command took more than 18 hours to reach the spacecraft, and the response took more than 18 hours to come back. Finally, Voyager 2 began returning science and telemetry data again. It was operating normally, the mission survived, but that moment revealed how thin the thread really is. One slight angle nearly ended a conversation that had lasted since 1977. The Deep Space Network is the only ear left. The only reason we can still hear Voyager 2 is the Deep Space Network, NASA's system of giant antennas in California, Spain, and Australia. These dishes listen for spacecraft across the solar system and beyond. For Voyager 2, they are not just useful, they are essential. The spacecraft's transmitter is weak, the distance is enormous, and the signal arriving at Earth is incredibly faint. Without the largest antennas on the planet, Voyager 2 might already be silent to us. This adds another layer to the warning. Space exploration is not only about spacecraft, it is about the infrastructure on Earth that keeps the conversation alive. A probe can survive in interstellar space, but if the systems listening on Earth fail, age, or become unavailable, the spacecraft might as well be gone. The mission is a chain: plutonium, transmitter, antenna pointing, deep space network, engineers, software, patience. Break one link and the most distant machine humanity has ever sent becomes unreachable. That is why the 2023 antenna incident was so frightening. It proved Voyager 2 did not need to explode or fail completely to vanish. It only had to look slightly away from home. The golden record changes the ending. Even after Voyager 2 stops transmitting, it will not stop moving. That is one of the strangest parts of the whole story. Eventually, the instruments will go silent. The transmitter will fail. NASA will send a command and receive no answer. But Voyager 2 itself will keep traveling through interstellar space, carrying the golden record bolted to its side. The golden record was assembled under the direction of Carl Sagan and his team as a message from Earth. It includes greetings in many languages, music, sounds from nature, images, and clues about who made it. It was never meant as a practical communication device in the normal sense. The odds of it being found are almost impossible to imagine. But symbolically, it is one of the most human objects ever created. A tiny archive of life on Earth attached to a machine, leaving home forever. This gives Voyager two identities. While it can still transmit, it is a scientist. After it goes silent, it becomes a monument, a drifting record, a fossil of civilization, a machine that once warned us about the edge of our solar system, then continued into the dark, carrying music, voices, and proof that someone once looked outward and wanted to be remembered. What NASA did not expect. NASA expected Voyager 2 to be historic. It did not expect it to become almost immortal by engineering standards. It did not expect a planetary mission launched in 1977 to still be shaping science in 2026. It did not expect that the spacecraft would help rewrite our understanding of the heliopause, reopen old questions about Uranus, and force engineers to invent new ways of saving power decades after its original mission ended. But the biggest surprise is emotional. Voyager 2 has become a story about borrowed time. It was built to visit planets. It ended up teaching us about the edge of the sun's influence. It was expected to die. It kept talking. It was nearly silenced by an antenna error. It came back. Its instruments are being switched off, yet the remaining ones still send unique data no other spacecraft can provide. That is why its transmission warns the world. Not because it predicts disaster, but because it reveals how much we still do not know. We barely understand the heliosphere. We have not returned to Uranus or Neptune. We have no replacement already operating beyond the heliopause. And the machine telling us all of this is running out of power. The real warning from Voyager 2. The real warning is about attention. Humanity often celebrates exploration at the moment of launch, landing, or flyby, but some of the most important discoveries happen long after the headlines fade. Voyager 2's greatest legacy may not be the beautiful images of Uranus and Neptune. It may be the invisible data from the border of interstellar space, the kind of data that arrives quietly and forces scientists to redraw the edge of the solar system. The warning is also about fragility. Earth feels large from the ground, but from Voyager 2's perspective, everything human is behind one distant point of light. Every government, every war, every city, every person, every ocean, every memory sits inside a small, protected region around one star. Voyager 2 reached the edge of that protection and found that the boundary is alive with pressure, particles, heat, and uncertainty. That does not mean we should panic. It means we should understand. The universe is not arranged for our comfort. The solar system is not sealed away from the galaxy. Our knowledge is not complete just because our diagrams look clean. Voyager 2's final transmissions are telling us that the frontier is still moving, still changing, and still full of surprises. So what do you think Voyager 2's final transmission will tell us? Will it reveal one last surprise from interstellar space, or will it simply stop one day without warning? Drop your thoughts in the comments. And if you want more stories about NASA's strangest signals, lost missions, and discoveries that changed how we see the universe, make sure to like this video, subscribe to the channel, and turn on notifications so you do not miss what comes next.